In this session, we are going to look into the next part of probability, that is nothing but multiplication theorem on probability. Now, what is this multiplication theorem? As the name itself says, multiplication. It means we will be asked to find out the probability, and the probability answer will be the product of two different things. Now, what is it? As we have already seen in the conditional probability, that if you want to find out the probability of A given B, this is nothing but a conditional probability, that we have to find out a probability of A given that B has already occurred. So this says that probability of A intersection B, we have to take out the intersection of both over probability of B. This is what the conditional probability is. Now, what is this multiplication theorem? Multiplication theorem is just the corollary of the conditional probability. What is corollary? It means that if you're going to revamp this formula, you're going to get multiplication theorem. Now, what is it? What are you going to find in this particular case? In this multiplication theorem, it says that if you're going to take out the probability of A intersection B, it means if you want to find out the probability that A and B both are going to happen or both are going to occur in a particular event, then what you do is you just cross multiply the other side, probability of B times the probability of A given B. Now, if you want to find out the probability of A intersection B, then you can take it as probability of the first event and the probability of the second event, provided first event has already happened. Or you can also take it in the other way, that is nothing but a probability of A times probability of B given A. It means if you take out probability of first event, then you have to multiply probability of second event given first event has already happened. So you're going to take two things here. If you're going to take probability of second event, then you have to multiply probability of first event given probability of second event has already happened. And if you're going to take out probability of first event, which is nothing but A, then you have to multiply probability of second event provided probability of first event has already happened. Okay, so let's try looking into the formula here. This is what the multiplication theorem on probability states. So if X and Y are two events associated with a random experiment, then probability of X intersection Y. So now here, you're going to take out X intersection Y. That is nothing but a probability of X times probability of Y given X. Is just a slash over there. Now in this particular case, you have to be very, very careful. The denominator part, which is X, that should never be equals to 0. This is very, very important over here. Or if you're going to take out the second part, probability of X intersection Y, you can take it out as probability of Y given probability of X, provided Y is already happened, where you're going to take probability of Y is not equals to 0. Now this is multiplication theorem for two events. Now what if you're going to get for three events? Probability that if first event is going to happen, second is going to happen, and also third event going to happen. Similarly, you can also apply for n number of events. Now let's try to understand for the probability of three events going to happen. Probability of E, F and G, all three is going to happen, where we are going to take E, F and G are the three different events. As you can see here, first thing, we are going to take it exactly as what we have done for the two events. Probability of E times probability of F given E. So now once this is done, then what you do is you take out the last term, that is probability of G, given that both probability of second and third are going to happen. So it's a very simple thing. What you want to do is, if you're going to consider, like I'll take a very basic example here. I'll take, there is a bag, or there's a container which has 5 blue and 6 red and 4 white balls. Now here you have to select 3 balls in random such that you will get 1 blue, 1 red and 1 white. So it means blue, red and white, all 3 should happen. So what you're going to do is, first you're going to find out probability of one event. Which one? You can take anything. Let us assume you're going to take out probability of blue is going to happen. Next what you're going to do, you have to find out the probability of R, provided blue is already taken. That's what it says. probability of F given that E is already taken. Next, you have to find out probability of Y. Now you are going to take out probability of Y provided B and R is already taken. That's what we are going to talk about in the third case. Probability of G given that probability of E and F is already done. So this is how you're going to take it out, and if they are going to ask for 4 terms, you can keep continuing it like this. I'll show a basic example for 4 terms. For example, if they have given probability of E, F, G and H. If this is the case, then what you can do is probability of E, this is the first one. You can even start with second one, doesn't matter here, times probability of F given E is done already, times probability of G given E and F is already done. Next, probability of H given that E, F, G has already happened. So this is how you can extend it to 4 terms as well, or even more number of terms. So this is all about multiplication theorem on probability. Now let's try going on with few of the questions. Before going on with the question, let's try going on with one example, then let's move on with the question. Now in this question they have said that what is the probability that hunter C kills a deer after both hunters A and B have fired at it once, assuming that it takes only one shot to kill a deer? If 3 hunters A, B and C can hit targets with the probabilities of 0.5, 0.4 and 0.1 respectively. And they have also given a hint there, a hunter's success is unaffected by the action of other hunters. It means they are saying that one is not affected by the other. Now in this particular case, very important information is assuming that it takes only one shot to kill the deer. Now if it is taking only one shot to kill the deer and they are asking us to find out the probability that C is going to kill. Now if C is going to kill, before that A and B would have fired, isn't it? Now if A and B would have fired, if one shot would have been shot to a deer would have been killed. It means that A and B has fired once, but they have not hit the target. So now we have to find out the probability of C provided that A and B has not hit the target. Now let's start with the solution here. Let the probability of hitting a deer be X. Now the probability of missing is going to be 1 minus X. If you're going to hit is X, then probability of missing is going to be 1 minus X. Now you can see here hunter C can kill the deer only if A and B have missed it. That's what I have already mentioned it. Now what we have to do is we have to make sure that A is missing. A is going to hit the target. That is nothing but probability of A hitting the target is 0.5. Now I need to find out probability of A not hitting the target. It is 1 minus 0.5, which is again 0.5. Next, B is also not going to hit. We know that probability of B is going to be 0.4. Then probability of B not hitting the target is going to be 0.6. Now we know that A is firing but not hitting the target. B is also firing, not hitting the target. I can say that probability is going to be product of these two. 0.5 times 0.6 is the probability that both of them not hitting the target. Now we have already got that both of them not hitting the target. Now they are asking us that C is hitting the target. Now we will multiply it. So it's like first one not hitting, second one not hitting, third one hitting the target. So it's a product of all the probabilities. So I'll take it out as 0.5, which is A not hitting the target, 0.6, which is B not hitting the target, 0.1 with C hitting the target. When you multiply all together, you will get 0.03 as the answer. Now let's look into a few of the questions here. Now the first question. Pens 3 red and 7 black in a bag. One by one at random, 2 pens are chosen without being replaced. What is the probability that the first pen chosen will be red if the second pen chosen also happens to be red? So now what we have a bag here, and in this bag we have got 3 red and 7 black. Now what is that they're asking about? One by one at random without being replaced. There is no replacement. What is the probability that first pen chosen will be red? Now I'll take out first pen is red. So probability of first being red. So now first being red, we have got total of 10 pens, out of which 3 is red. I can take it as 3 over 10. Next, if I want to find out the second one also red, so it means I'm going to take out probability of second red given that first one is red. Given first is red. Now if first is already been taken, I can see the new box is going to be, it has got 2 red and 7 black. Why 2 red here? Because we have already taken 1 red. Now in this particular case, the second one will be red here as 2 reds among a total of 9. Now they are asking us what is the probability that the first pen chosen will be red if the second pen chosen also happens to be red. It means that they are talking about probability of first red intersection the second red. So now this can be taken from the multiplication theorem, which says probability of A intersection B is given by probability of A times probability of B given A. We have already got this. Probability of A, that is nothing but first one is red, is nothing but 3 over 10 times probability of B given A. It means second one is red given first one is also red, is nothing but 2 over 9. I can take it as 3 over 45. I can further simplify as 1 over 15 as the final answer. Now let's look into next question. This question is based on assertion and reasoning. So here in this question, assertion part, they have said that 3 children X, Y and Z took part in a racing competition in their school with their respective probabilities to reach the finishing point being 1 over 3, 1 over 5 and 1 over 4 respectively. The probability that at least one of them will finish the race is given by 3 over 5. So now in order to simplify this, what we can do is we'll just try to understand this and we'll try to solve it a little bit more faster, because it's just an assertion and reasoning problem. So now they have said that probability at least one of them will finish the race. At least one of them will finish the race. Can I say that probability, required probability is given by 1 minus probability that none of them will finish the race? If I'm going to take 1 minus none of them, it means that at least one of them will finish the race. That will be very easy. So now if I want to find out none of them, I can say 1 minus probability that first one will not finish the race, which is going to be 1 over 3 is finishing the race, 2 over 3 will be not finishing the race, times 1 by 5 will be finishing the race, 4 over 5 will be not finishing the race, 1 over 4 is finishing the race and 3 over 4 is not finishing the race. So now if I'm going to take this out, 1 minus, I can cancel out 3 and 3, 4 and 4, it will be 1 minus 2 over 5, which is nothing but 3 over 5. So now this is what we have got answer from the assertion part. So this is correct in terms of assertion. Now I can see that assertion is right. They have given the question and they have said their answer is going to be 3 over 5. Yes, it's right. Now let's look into the reasoning part. Probability of at least one of them reaching the finishing point is nothing but 1 minus p of none of them finishing the race. That is nothing but 1 minus p of x bar, y bar and z bar. Yes, that's what we have done in the first and second step. Yes, both assertion and reasoning are true and reason is the correct explanation of A. So I can go out with answer option A. Now let's look into a few more questions. One bag holds 4 yellow, 5 green and 2 red caps. First, let's draw the setup of the bag. 4 yellow, 5 green and 2 red caps. Determine the probability that of the 4 caps picked at random, at least 3 will be LO. So now in this case, they have asked us to find out at least 3 is LO. Now you're going to pick up 4 caps, out of which at least 3 is LO. It means that you're going to find out the required probability as probability is going to be probability of exactly 3 LO plus probability of exactly 4 LO, which is nothing but all are LO. So this is what we are going to take it out. At least means either it can be 3 or it can be 4. We don't have 5 because we are going to pick up maximum of 4 items. Now if I'm going to look into exactly 4 LO, so it's very simple. You have got 4 LOs and you have got overall of 11. So what is the probability that you will pick all the 4 LOs? The first one you select is LO. So I can take it as LO, LO, LO and LO. So if you're going to take this out, I can say the first one is 4 out of 11, second one is 3 out of 10, next is 2 out of 9 and 1 out of 8. This is selecting 4 items, all are LO here. Next is probability that exactly 3 LOs. So I can say LO, LO, LO and 1 more item. So now if I'm going to consider this one, you are going to select 3 LOs with 1 more item, but that 1 item can be anywhere. So it means that you are going to have 4 different combinations again. So first let me take out 3 LOs. So I can take out a first one LO as 4 over 11, second LO as 3 over 10 and third LO as 2 over 9. If you're going to select 3 LOs, left out will be 1 LO, 5 green and 1 red. So now if you're going to look into this, among this you should not take LO. So total is going to be 8. Among this 8, you're going to select the 7. So I can take out the remaining one is 7 over 8. But you can take it out in any order. The one which is not LO, you could have picked in any order. So that's why I can take it out 4, because this dash can be taken in any of the 4 positions. So now I can take out the total one as 3 1 times, 3 3 times, and I can take 4 1 times, 4 2 times, 2 2 gets cancelled, and I can again take out 2 2 times and 2 5 times. I'll be getting it out as 14 over 11 5 times 55. 55 3 times is 165 plus I can even cancel on this side 3 1 times 3 3 times 2 1 times 2 4 times, where 4 and 4 gets cancelled. I'll be left out with again 1 over 110 times 3, which is going to be 330. So now if I'm going to look into this, this has an LCM of 330. So 165 2 times, so it is going to be 14 2 times, which is going to be 28. 28 plus 1 gives 29. So our final answer is going to be 29 over 330. So I hope you guys are clear with this. So it's just about multiplication theorem, and we keep on multiplying based on the condition given. And in the first case, you have to be very, very careful, because in that case, they have not mentioned that first one is non-LO, second one is not non-LO. They have not mentioned anything about that. So non-LO can be of any place. So there are total of 4 places. It can be taken in 4 different ways. That's why I have multiplied 4 in the beginning. I hope it is clear. Now let's move on with the next question. A bag contains 5 red and 3 blue balls. The probability that exactly 2 of the 3 balls were red, the first being red, is. Yes, now here you can try applying the multiplication theorem, or even you can apply in a normal way. Okay, I'll just write down the setup of a bag. 5 red and 3 blue balls. Okay, in this case, we need to find out the probability. That required probability is 2 of the 3 balls are red. So now if I'm going to think about the setup, it is generally RRB. Now in that case, they have told first ball being red. Now first ball is fixed. The other 2 can be changed. So I can take R, B and R. So we have got 2 possibilities. So I can take this out as probability of R1 intersection R2 intersection B3. This is the first case. Plus, so we have to take out this setup or this setup. Both are going to be working. That's why we are going to take out plus, or I can even take in terms of union here. So I can take it as probability of R1 intersection B2 intersection R3. Now if I'm going to apply multiplication theorem here, it says probability of R1, that's the first one, probability of R2 given R1 is already taken, and probability of B3 provided R1 and R2 is already taken. This is the first case, plus probability of R1 times probability of B2 provided R1 is already taken times probability of R3 given that R1 and B2 is already taken. So now we have to solve it one by one. The first one, probability of selecting R1. So now first ball is red. So I can say 5 out of 8. That's the first case. 5 out of 8 times. If I'm going to take out R1, left out is 4 red and 3 blue. So for that I can say 4 over 7. Next, if I have taken 2 R's, then left out is 3 red and 3 blue. So I can take it as 3 over a total of 6. Plus probability of R1 once again, which is going to be 5 over 8 times probability of second one is blue given R1 is already taken. If I'm going to remove R1, left out is 4 R1 with 3 blues. So I can take it as total is 7 with the blue is 3. I can take it as 3 over 7 times 1 red and 1 blue is taken. So 4 red and 2 blues are left out. Out of 6, I have to select 1 red. So it is going to be 4 over 6. So I need to solve this now. 4 1 times, 4 2 times. And I can take it as 3 1 times, 3 2 times. We have got 5 over 7 times 2 times 2, which is going to be 7 4 times 28. Plus 4 1 times, 4 2 times, 3 1 times and 3 2 times. Again, I have got it as 5 over 28, which is nothing but 10 over 28, or I can also say it as 5 over 14 as the final answer. So I hope you guys are clear with this multiplication theorem on probability. So what is that we have understood here? We need to look into the given condition. So based on that, whatever they have said, for example, if they have said you have to select a second one, provided the first one is already taken, then you can apply the condition probability. And if you're going to use the multiplication, that is nothing but a multiplication theorem on it. I hope you have clearly understood the multiplication theorem on probability. Thank you.